Okay, we're going to have a look at another syllabus dot point, the angle in the alternate segment theorem. I'm going to try and prove this theorem. So what we're trying to do is prove that the angle between a tangent and a chord. So a tangent on a chord, let's just pop that onto our diagram here. So we've got our tangent AE just touching the circle, and we want the angle between that tangent and the chord AB. And we want to show that that's equal to the angle in the alternate segment. Now we've got this chord that divides the circle into two parts. We've got one segment in here, and then we've got the alternate segment is this one over here. So the segment, if you like, the angle's not in, so it's the alternate segment. So what we want to do here is find, we want to show that the angle between the tangent and the chord, angle EAB, is equal to some angle in that other segment, the alternate segment. And we're going to use point C here to show that angle. Could be any, that point C could be any point on that segment, on the circumference of that segment. So we're going to pop it there. And so we want to show that this angle here, angle BCA, is equal, the angle in the alternate segment is equal to angle BAE, the angle between the tangent and the chord. Okay, so let's pop that down as a required to prove for our proof. So we're required to prove that angle, let's say BAE, is equal to angle, that's the angle between the tangent and the chord, is equal to angle BCA, which is the angle in the alternate segment. Now to do this, we're going to introduce a diameter. So let me use a different colour here perhaps. So we'll put a centre of the circle here, and just going to draw a diameter going through that centre out to point D. So we've got point O here, and then we get another triangle or an angle on the circumference, if you like, an angle in the semicircle, in fact. Yeah. Okay, so the first couple of things we can note here is, first of all, that the angle in a semicircle is equal to a right angle. So we've got this sort of right angle in here. That's one of our previous theorems. So we'll write that down with our proof. We've got angle DCA is equal to 90 degrees, reason being that angle in a semicircle equals 90 degrees, or is right angled. So we've got that information. Now what we might do to help us with our proof as well is, let's call this angle here x degrees. So we'll let angle BCA equal to x. And then from there we can easily see that the angle in here, angle, what's that, DCB, angle DCB is just going to be equal to 90 take away x. No real need to put a reason for that, that's pretty evident there. I'll write that in there as well on the diagram. We've got 90 take x there now. Now at this point here we've got another circle theorem we can use, a previous circle theorem that's already been proven. And it's the angles from the same arc. So if we take this arc from D to B over here, and then we've got the angle out here, DCB, we already know that one's 90 take x, and then we've got the angle, whoops, it doesn't come out too thick when I go straight down like that, angle DAB. So they're both angles from the same arc. So what it means is that this angle in here, angle DAB, is also equal to 90 take x, and that would be reason for that, angles at circumference from the same arc are equal. Now at this point here, let's write that in as well. We've got on our diagram, we've now got that one being equal to 90 take x. So at that point there, we've got a third circle theorem we can use, which is the fact that a tangent makes a right angle to the radius of a circle. So if you've got the tangent AE here, That actually makes a right angle to that radius AO or AO or AD if you like. So let's write that down. So angle OAE, let's just make sure I got that right. OAE, that'll work, is equal to 90 degrees. Let's say tangent at right angle to radius is our reason. And then if that's the case, we know that therefore the angle that we're trying to find, this one in here, which is angle BAE, is just going to be equal to the right angle 90 degrees, take 90, take x. So angle BAE, oops, try that again. So angle BAE will be equal to 90, take away the 90, take x. And of course that's equal to 90, take 90 plus x, which is equal to x degrees. So we get to our what we were trying to prove in the first place, that BAE is equal to angle BCA, which is equal to x degrees as required. And our proof is done.